Okay, let's get this screens on. We're going to start unit 4 today. That screen's not. Okay, so we're going to start unit 4. Um, because there are more things to if-thens and more complicated if-thens, and if-get-thens are really kind of important to a lot of our programming stuff. We're going to spend kind of another week on this if-then sort of decision stuff. We're going to look at another statement called a switch statement, which can replace a bunch of if-thens. We're going to look at some like Boolean logic, where we can do some ands and ors, or different ways of grouping if-then statements. And we're going to look at how we can use if-thens, do comparisons and Booleans with strings and objects like that, because we can't just check if one string is equal to another string, and we'll talk about that. So we're going to really, there's a couple other issues we're going to just deal with here as far as just additional stuff, formatting text and getting random numbers and stuff. There's a couple other things we just throw in there, but much of this is just diving a little deeper into if-then statements here and how that works. So I'm just going to jump into this learning material and go through it. So again, there's a bunch of topics. We'll talk about nested if-thens. We'll talk about logical operators, the switch statement here, string comparisons, random numbers, casting and formatting output. So those are some of the things we're trying to get to this week for this. The first one is kind of nested if-thens. We kind of looked at this last week, and we're doing this with the if-then, else-if statement here. So remember, we talked about we could say if some expression, and then we could do else if another expression, and then we could do an else. And this else then only happened if none of the above statements were done there. So we do if, else here to have a bunch of selections. You know, it either does this statement 1, statement 2, or statement 3. It'll never do more than one of those here. So we talked about that sort of setup with this else if. So that's one way of structuring if-thens. But there are other ways. I'm going to jump into this Think Java version again. So they talk about chaining is what they call the else if, where we do if, else here. We can also do if statements within other if statements. So here, or we could say like if x is greater than 0, say positive, else, and then start a whole new block and say if x is less than 0, do negative, else if x is 0, else just say x is 0. So again, we can put a whole if then within another if then structure, and we can do more complicated stuff with that. And in fact, we can stick another if then here. We could check something here and something here and do multiple if thens, and we'll look at some options with that in just a sec. So that's kind of our if thens. Intro to Java talks about the same thing and how they, in some ways, this particular structure is equivalent to this. But again, there are options as far as putting in an if then inside another if then and some options here. I like how this has a nice kind of an example of this chaining. If we test this, if it's true, we do this. Else, we do another test. And if that's true, we do this. But if that's false, we do another test. That's true, we do this. Otherwise, we do this. So we can kind of chain together these if then statements here. So let's look at an example here. And again, there's a nice video where Chris walks you through this example also. This is the driver's license test from last week. And I'm not going to redo this here. I'm just going, or, I'm just going to walk through. I'm not going to necessarily run this code for this example. We have lots of examples we can look at today. So last week, we were just basically looking at what's your age here, and we'd read that in, and we'd do, if the age is greater than 15, you can drive. If you are 15, you can drive with a permit. If you're 14, you can use a farm permit. Otherwise, you can't drive. But what if we added some other requirements? What if we said, well, if you're over 15, you have to take the driver's test, and you have to score at least 80 on that before you can drive. So then we can do things like say, if your age is 15, and then have another if then inside here. If the score is greater than or equal to 80, then you can drive. So again, we have our first if then, and then we have another if then inside that. This is where we have to watch. It really helps to do your indenting correct. When we start getting these complicated structures, again, I've been suggesting we try to do indenting. So every time we go inside an if then, we want to indent a little further here. And most of our 8 IDEs will do that, but sometimes we lose that. So you want to try to keep your indenting so we can kind of see this if starts here and ends here. And this is if then inside there. Also, if you're 15, you need to score 85 on your permit so you can drive. So this checks that. So again, we put an if inside this if. Well, it's actually part of an else if there. And then we go through the rest of these. So this is kind of the idea of this sort of stuff where we're putting ifs around there. Now, one other thing we can do, just to make it even more fun, is we can do these, close some of these off. We can use these Boolean expressions or logical operators. They're the same, basically. We have the and that's an and%, an or, that's 2 vertical lines. So the vertical lines are, in my keyboard here, they're right above the enter key, and I have to hold down shift to do them. The and% is always above the 7 here. Sometimes the vertical lines above the left tab, depending on your keyboard, sometimes it changes. So look for the vertical lines. And you may not, I mean, I know you probably have typed ampersands before, right? You've typed these before. You may not have really done, this is one, it looks like an L or something, but it's a vertical line here. So these are 2 vertical lines here. And then the exclamation point is our not here. So we can do things like, we can check if one thing or another thing. I don't love these example here. I like this example. So here, we can ask if the score is less than 0 or the score is greater than 100, then it's an illegal score. And then we can say if the score is greater than or equal to 0 and the score is less than or equal to 100, then it's in the range 0 to 100 for this. So again, this is how we could test for or here. Now I often will put parentheses around this. Let me just bring this into NetBeans real quick so I can show you this part. Okay, I'm just going to grab this main section out of here and bring it over here so I can try it out. So here we have the score here. Again, we could ask the user to enter the score here. That might be a better way of doing this, but let's say we have a score variable. Then we can say if the score is less than 0 or the score is greater than 100. Now, like I say, I often will put these two parts, this part in parentheses, and this part over here in parentheses. So it's clear what I'm doing here. So I often will set it up something like that. And I'm going to put one more space here. So I'll say something like this. If the score is less than 0 in parentheses, or the score is greater than 100, then we do that. Now you don't have to. You can do it without the parentheses in some cases, in a lot of cases. But again, I tend to overuse parentheses just out of because of extra precautions. One of the things you have to remember is that, so you know the order of precedence for math operators, multiplication, divide. So if I say something like here, let's just say, if I say score equals 100, or 100 times 4, let's say plus 4 times 20. If I say something like that without any parentheses, you know that multiplication happens before addition here. So it's going to do this. And so that's why we would typically write it with a parenthesis just to we wouldn't need a parenthesis there, but it just makes it more obvious that that's the case. Well, just like there's precedence for that, there's precedence for all the operators. So or will happen, less than and greater than will happen before or in most cases. But there are some operators that don't happen in the precedence you might want them to here when we get into some strange operators. So that's why, again, it's sometimes nice to put some parentheses here. Okay. So we got these ands and we've got these ors here. And again, to enter those, you just enter shift vertical line for those. Okay, let's look at some more. So Think Java goes through and talks about these same sorts of operators here. Talks about the not operator. So like if it's not true, so we can say is x greater than 0, or we can say if it's not true that x is greater than 0. So this is really like just saying if x is less than or equal to 0 in this case. But often there are some places where the not is useful because there's not an obvious way to switch it to a not, an easy way to switch it to a not for this. So again, sometimes when we do this, if x is equal to 0, and if so, if y is equal to 0, then we print off both x and 0. We can combine those into one if-then statement. And again, there's lots of ways once we get into all this stuff to set up your if-then statements. There's not necessarily a right and a wrong way. I mean, there are obvious wrong ways that don't do what you want, but there's lots of solutions. You know, I can often write 4 different if-then statements that all do the same thing once we get into these complex structures. Here. For example, here, we were looking at these driver's license stuff. We could write this with the ampersands. So we could say like if age is equal to 15 and score is greater than or equal to 85. That's the same as this here, where we're checking if the age is 15, then check if the score is greater than or equal to 85. So these two are basically the same for this. So we can rewrite them in different ways. Now you can also combine these. Chris gives the example where, well, if your age is more than 15 and you score 80 on the exam, you can drive. But let's just say you were to pay a little extra in your fee to the driver's license person, and you were to pay like $1 million to them rather than the normal, $20 fee. Well, then maybe they'd let you drive then if it was not. So he added this, or if the fee is greater than or equal to $1 million, then you can drive. So again, we can write this sort of stuff with ands and ors. And again, they put in some parentheses here to make it clear what goes in what order here. Now, one thing we can't do is we can't put commas in our numbers in Java. We can put underlines. Underlines are optional. You can put them anywhere you want. So sometimes when we're formatting things like a million, it's nice just to put the underline in there instead of a comma, or you might be used to putting a period or a dot between them some places. So that's what we're doing here. In CS Awesome, there are some, if you want to, there's some nice examples of ands and ors here. They talk about truth tables, which are kind of cool. If you've had a logic class or whatever, they talk about setting up truth tables and saying if one thing is true and another thing is true, is the two ands together. So if P is true and Q is true, is P and Q true, and setting that up. They talk about or all these truth tables, and they actually get a little bit into well, again, they have a whole exercise in Pogo. Oops, I think it's on the next page where they yeah. Mr. Morgan's Law, again, if you take a logic course or something like that, you'll learn these rules and how you can kind of translate. If you say not A and B, that's equivalent of not A or not B. And there's a number of logical rules like this where you can convert one Boolean statement into another Boolean statement. We don't really need that, but in this class, I just think it's kind of cool and they show it here. So. Okay, so sometimes we'll be chaining a bunch of statements together and with if then, else if, else ifs. And so there's a special statement for that that's called the switch statement. So if you have this, if the number equals 1, we're going to say 1. If the number else, if the number is 2, we're going to say 2. Else, if the number is 3, we're going to say 3. Else, we're going to say unknown. If you have that sort of structure, and it's pretty common, we can replace it with what is called a switch statement. We can say switch on the number, and case of 1, then we do what we want. Case of 2, then we do what we want. Case 3, we say what we want, and then default is it. So this and this are the same basic logic for this. Couple things you have to watch. When you're doing a switch statement, there has to be a break after every case. Here, you have to have a break after every case. Very important with switch, and it's common error. Before your time, but in my time, we had back before we all had like cell phones and stuff like that. And we did before we had even email that much. We used to use the telephone a lot, and especially on Mother's Day. There'd be lots of phone calls to home wishing your mom a happy Mother's Day for this. Well, on that day, one of the switches in the United States, one of the phone switches, which all run on computers, got overloaded and had an error statement. And it went through and there wasn't a case. So there was an error statement that did something like print out error message, but there wasn't a break statement here. The coders had forgotten it. And then it went down to the next one, which was to shut down the whole computer, the switch, the phone switch. And it shut down the whole phone switch there, which would have been bad. That one little town would have just not had phone service for about 10 minutes while the phone switch turned off. But it shut down, and that caused this cascading error to all the neighboring phone switches. So all the neighboring phone switches had that same error where they printed off the error message, this break was missing, and then they went, so the break was missing, they went down to the next severe case and they shut their switches down. And so all the switches, phone switches in the entire United States shut down, and they would start coming up. But as they came up, a neighboring switch would tell them to shut down. And so they would shut down. And so for a whole day, almost a day and a half, all the phones were just not working in the entire United States. And they traced it all back to one programmer forgetting one break statement in one line of the switch stuff. So again, remember to put in your break statements if you do switches here. Okay, so that's a switch statement. Internal programming walks through the same thing here and talks about more advanced ways of doing cases. There's, if you want 2, 4, and 8, all do the same thing, and 3, you can do more complicated stuff here. And then this menu, and this is what we'll look at, how to display a menu and do a switch based on a menu for this. So that's an option. So we're going to look at 2 examples of this. First, we're going to look at this math example. We actually did this a little bit, although we kind of skipped this example last week. We're going to print a menu to do different arithmetic things to a number. So we ask the user to enter a number. Then we say, do you want to add 100 to it or subtract 50, multiply it by 2, divide by 3. So those are our menu options. And then again, we're going to read in their choice. It'll be 1, 2, 3, 4, or 5. And then we're going to say switch on choice here. And then we're going to say case if it's a 1. Now, rather than actually putting a 1 here, we're going to declare another variable called add equals 1, subtract equals 2, multiply equals 3. So we're going to have some constants up here to do this. So we're going to say case add, and then we're going to take a number, add 100. If it's case subtract, we're going to take our number, subtract 50. And after each one, we're going to do a break statement here. So these are our commands for our menu system for this. Let's look at another example of this. And I'm going to do, I think, this one. NetBeans will often automatically, will ask you if you want to convert if-then switch to switch statements for you. So I'm going to download this sample here. I'm going to uncompress it. And I'm going to open it up. I'm going to switch to NetBeans and open it up. Oops, let's see. There. Okay. Let's open up the actual code here. Get rid of these. I'm not using those. Okay, so again, I'm just going to display a menu. This is the Pizza Luce review question from last week. We display some options that are available at this restaurant here. 1, 2, 3, 4, and we ask the user to enter an integer. And now we have this big long if statement. If menu order number equals 1, we say this. If menu order number equals 2, we say, oh, you're going to get the chicken parmesan. 3, your pesto turkey. 4, 5. Otherwise, we say, sorry, you must select something off the menu. So that is an if-then structure. I'm just going to make a copy of that. Now, there's a hint here, and we can click here, and one of the options is to convert the ifs into a switch statement. Because this is so common to set this up, there's an automatic thing to do this. And so it'll convert this all into a switch statement here. I'll show you the results here. Okay, so here's the if statement before, and here's how it was changed into a switch statement for this. So again, NetBeans, you'll watch it sometime. It'll ask you and it will convert this for you. So if you have a set of if-then structures, there's often a little hint here. And if you click on that, it'll just let you convert it to a switch statement. So that's why it kind of shows that this is equivalent for that. I'll just tell you, I'm not a big fan of switch statements. I don't use them very much. I use if-thens a lot more. But some people like to use them. And there are some special cases like these menus and stuff where they really work well for those stuff. Okay, so let's let's do our last thing here. We're gonna now start talking about comparing strings, and this is what I think you'll use the most. I want you to start using here is comparing strings here. So let's talk about comparing objects and strings for this. Now, strings are what we call an object, and objects are kind of weird in that when we say if one object is equal to another, like equals, if equivalent to another, it doesn't actually compare them part by part. It compares some internal stuff, the memory address where they're stored at for this. And so we can get into some trouble with strings and how they work. They actually work with what we call pointers, and it's not, if you're going to do lots of programming, this isn't a bad thing to watch some of the, or work through these videos and see what happens when we do things like say one string is equal to another string here. And how that is different than when we say one integer is equal to another integer for this. But when we check if strings are equal, we can't do this equals equals. We have to say string 1 equals string 2 in this example. Let's look at this one. So I want you to set up this code here and try to get this to work. We're just going to ask the user what's their favorite color. And then based on that favorite color, we're going to say something. So if you want, just create a new project. And this is just going to be a color or favorite color unit for favorite color. And just ask the user enter their favorite color and enter that into a string here. So we're going to do system.out.println. What is your favorite color? We're going to read that in to a string. We're going to need a scanner. So let's declare our scanner up above. And we're going to have to do our import of our scanner up here. Okay, so now let's do this again. Input dot next line. So then you want to do something about that color here. Maybe you'll predict their personality based on their color or just make up something there. So maybe we want to say what kind of sports fan they are here. So I have friends who are Green Bay Packer fans. Their main color is green. I have friends that are Vikings fans and their big color is purple. So I'm going to ask, check if the color is purple, if color equals purple. Oops. I'm going to print off go Vikings. And I'm going to do the same thing if their color is green. I'm going to say go Packers. And again, now there's warnings here because the way I'm doing this is not correct here. And we're going to try that out. So now I'm going to run this. I'm going to say, what's my favorite color? I'm going to say it is purple. But it doesn't tell me that to go Vikings, even though I typed in purple and it checked color is purple. This is not how we check if two colors are the same here. So we can't check that. We have to say if color dot equals, and then we have to put in our purple inside that. So we have to say, it's kind of a weird format here. Oops. So we have to say if color dot equals purple for this to work. So we can't say if color equals is equivalent to purple. We have to say dot equals purple. And I have to do that for this one too. And that's why there's this warning comparing strings using equals. We generally do not want to do that. So again, set this up, ask what your favorite color is, read it in, and then check 2 or 3 different colors and print out different things and see if you can get that to work so that it will do that. And I'll wander around. If you need some help, call me over and I can help you out with that. So see if you can get this set up to ask for your favorite color. Often when we're comparing strings, we want people to be able to maybe enter them with an uppercase, lowercase here, because sometimes people will just capitalize words, stuff like that. So if I run this and I enter just purple, it works fine. It says go Vikings. But if I run this again and I type in purple with a capital P, seems like a fine favorite color. It won't say it'll, in this case, mine says go Lynx. Lynx are just better than the Vikings and the Packers anyway, so that's okay, right? Okay, so, but what if we wanted to actually do the right thing? If it's purple or green we want. So we want to check, what if they entered an uppercase P here? So we could do some, use our ors here. If the color equals purple or color dot equals, and we check if it equals purple with a capital P. So if it lowercase p or a capital one P, if it's either one of those, it will say Vikings. So I could do something like that, which works as long as I enter one of those ones. But what if I'm really excited about purple and I want to scream out purple all in caps? If I enter it all in caps, I'm a Lynx fan again here. So how do I do it? So I could add another or here. But this is getting kind of long here for this. If only there were a better way for this. So rather than doing all that here, there's another alternative. If I say if color dot and I start typing equals, I see another one right below this. Equals ignore case. So equals ignore case will check if two strings are equal, regardless of uppercase, lowercase, if they're capitalization there. So that's a nice way of doing it. Another way to do this is I could make both strings, like convert both strings to uppercase and then compare them if they're equals there. So that's another way you do it in some languages. But this has enough equals ignore case. So often when you're doing color, if one string equals the other, ask yourself if you're at all worried about if it's case sensitive. If not, use equals dot ignore case for this. So now if I type this in and I type in green and do any sort of case I want, as long as it's those letters, oops, and I spell green correctly. Let's try it again. Green. Okay, then it'll work fine. Okay, so there's this equals ignore case. Questions on this comparing strings? So just remember, whenever you're going to compare strings, you don't do equals equals. You have to do this. Whatever one string is, dot is equal to another string. All right. Let's just jump to a couple other quick things. Let's talk about random numbers a little bit. So often in our programs, we'll want to generate some random numbers. This looks like it went to the wrong spot. Okay. Look here, this. All right, well, I'll update that link. Okay, so let's just look at the examples here. So sometimes we want to generate a random numbers, and there's two ways of generating a random number, two common ways. Normally, I would just show you one and say, just use this way, and you don't have to worry about the other way. But again, with everyone using AI a lot to write code, AI tends to, some AI show one, some AI show the other one, or they just randomly pick one here. So it's good to be aware of both because they're slightly different here. So I'm gonna make a new project here called just unit for random numbers. And I'm going to start with this math.random way of doing things. So I'm just going to grab this main program and put that over here so we can look at it. So there are a couple, the simplest, well, I don't know if it's simplest. One way to generate the round numbers is with the math library. You can say math.random here, and this will give you a random double between 0 and 1. It could be 0. It won't be as big as 1. It'll be something less than 1. So to give you a random number between 0 and up to, but not including 1 here. It always gives you that. So if we want a number between 0 and 1, we can just print it off. So we can say random, here's our random double equals math.random, and we can just print that out here. But what if we want a random integer between like 0 and 100? So what we can do is we can take that random number, math.random, and we can multiply it by 100. So if it's 0, 0 times 100 is 0. And then if it's 1, it'll be 1 times 100 will be 100. Okay, it'll never be 1. It could be like 0.999. If it's 0.99 times 100, it'll be 99. So it can be there. Now, we can do this, and then we also will, this is still a double here. We're going to convert it into an integer for this. And this is what is called cast this converts it to an integer and throws out any of the decimal parts of it. So if we do this, this will give us a random integer between 0 and 99 for this. So what if we want to do a dice? We just want to roll a dice, and dice are valued like 1 to 6. Or maybe you have a 10-sided dice, 1 to 10, or a 20-sided dice. How would you do that? So again, we do math.random. We multiply it by 10, and then we can add 1 to it. And that'll be a number between 1 and 10. So if we want a number between 1 and 10, we have to do this. So where math.random is simple to start with, to do more complicated things like this, it gets a little harder for us to do. But this will work if we run this. Here's our random double, between 0 and 1. Here's our random integer between 0 and 99. It picked 1. That's interesting. Well, not it's random, I guess. And random integer was 10. And if I run this again, I'll get different values here. Now my random integer between 0 and 99 is 51. And my random here is 10. And now it's 67 and 6 here. So every time I run it, it'll give me different, that's the whole idea. Or this. To generate these. We call these pseudo-random numbers because we actually use a complex math equation to generate them. So there is kind of an underlying pattern, but you generally can't see it because they're pseudo. It's pretty well hidden here. So these are pseudo-random numbers here. Okay, let's look at this other way. And this is the way I prefer to do it, is this way. Here, I'm going to just put this all in comments. Here, source. I'm not used to, I've got to learn how to do my comments in this, in NetBeans. I use 3 different IDEs right now, so I never remember which one does. Oh yeah, control / will put these all in. So again, if I just highlight some code and want to comment all that code, here I can just hit control / here. Okay, so I'm going to do this with this random library. So I'm going to grab this code here, paste it in here. And with this, I do need to do an include here and import. So I have to do import javautil.random here. Math is, I don't have to do it with math because math is imported automatically in all Java programs. So again, I also need a random object. So this is a kind of a 2-step process. And so some people think it's harder. So I create a random object with it called random. And then that random object, or that this is a random number generator, I can do things like say random.nextDouble, and it'll give me a double. I can, if I want an integer between 0 and 99, I can just say random next int and then specify 100. And it'll give me an integer, and it'll give me an integer between 0 and whatever that number is for here. And again, if I want a number between 1 and 10, not 0 and 9. So if I just say this random integer 10, that'll give me 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but never give me 10, but will include 0 in it. So if I want a value like this, I could go random integer between 10, or random int of 10 plus 1. So again, let's say I just wanted to roll a 6-sided dice. I would change this so that, let me change the comments too. So random int of 6 plus 1, that will start at 1 and go to 6 for this. So now I can run these, and then here's my random numbers. So just know there are different ways of generating these random numbers out there. And you'll see them. I will tend to use this random one, I think, in most of the examples. We'll see here. Again, Chris does some of these examples, and again, different people use different examples. I'm trying to remember throughout the course. So just know that some of the times we'll use random numbers. I find it really helpful to have a sample project somewhere that has random numbers in it because I always forget. And again, you can always ask AI to do it and help you out here, but it's nice to have just a sample out here for random numbers, or you can always look back at this example. Let's look at one more thing today. And again, Mondays are going to be a fair amount of this talking stuff. And then Wednesdays, what are we going to do tomorrow, you ask? Oh, we get to do the BuzzFeed quiz tomorrow. So tomorrow we're going to do the BuzzFeed quiz. I don't know if you're familiar. There used to be a big thing. When did BuzzFeed quizzes come out? 2000s, something like that. You remember, like BuzzFeed quizzes are like, which Harry Potter character are you? And you take a quiz, answer these 6 questions, and it says, which house you're in or which character you're like, or that sort of stuff there. I'm old, so I'm used to the which Friends character are you, or something like that. So there are different examples, and I just always call these BuzzFeed questions because there was a website called BuzzFeed that had that just rose to fame mainly by doing quizzes like this. So tomorrow we're going to do that. You're going to do your own BuzzFeed quiz, and then for the assignment this week, you have a choice between 2 different problems, and you get to choose whichever problem you want. You might try to pick the easier of the 2 problems, but I'm pretty sure they're very similar. I mean, we've structured these to be very similar. So I don't think one is easier than the other. They're just 2 different problems of setting up if-then structures here. So, okay, so let's go back, finish this up. So that's tomorrow. Wednesday we'll just be working on that BuzzFeed quiz and stuff like this. The last thing we need to talk about is just a couple more things. Formatting. Let's talk a little bit about formatting. Well, let's just mention casting because we talked about that originally. If you have like a double and you want to convert it to an integer here, you can do what is called a cast. You can take that double and just say, and we put before it, we put the type we want it to be converted with. And basically it says like, take this cookie color template and put it over this. So it's like, here's your pi, 3.1415. And now we're going to take an integer and take that integer cookie cutter and put it over pi. And that's going to give us the 3 part of this here. So it's going to convert that to a 3 here. So casting is good when you have a something with more data, like a double, and you convert it to an integer. It doesn't work when you're going from a string to an integer here. So in general, we can't take a string and cast it to an integer. It's going to give us an error, incompatible types there. So when we're converting to and from strings, we have to do things like convert them directly. It is so. Oh, this one didn't have one. There's. Well, we'll see. There's for like integers and doubles. There's you can go from convert string to double and integer to double here with a conversion. So we'll look at that later on. But we just want to mention string. Now let's talk about printing and formatting output. So if we print, just use our print command and print out like 4 divided by 3, that's 1 1/3. It's going to print off like this. What if we only want to limit how many decimal places we want? So rather than doing print, we do a printf, which is print with formatting. And then to do that, we specify the string we want to use to format it. And in particular, that string has to have a template for our number. And the template always starts with a % and then a character like F for floating point number, D for decimal, S for string here. And then it can include some optional formatting like 3 decimal places. So this says, print out 4/3 equals, and then stick in a number with 3 and round it to 3 decimal places. And it's a decimal number here. And then we'd say comma and this. Now there's a whole thing about string formatting and how do you do printfs and that sort of stuff. I'm not going to dive too much into printfs here. Some of these books will like them. Some places now are replacing these with a string.format command. So there are other commands out there for this. So this talks about this, but there are other ways of doing output rather than printf. So just know that there are ways, and it now sometimes it's just probably easier for you to just ask AI to do it, or to look or ask Google how to do it, and see what you'll see. So sometimes you'll see these printfs set up. Sometimes you'll see other string.format commands here. One reason why printfs aren't used that much is that we rarely actually print to the console anymore. And printfs only work with printing to the console. We are often like displaying it on the screen in a box or on your phone or something like that. And in all those cases, like when I teach the Java course, the Android app development course, we never use prints there because again, we're always writing to different parts of your phone screen and you don't print there. You just set that string or, into this text box or something like that. And we use a string.format for that. So a lot of these things, intro courses talk a lot about printfs. I just don't think they're really that important long term. So I'm not going to stress them as much here. There's a nice little average here. Again, we ask for 3 integers. We calculate the average of the 3 integers and we print them out. And again, we're going to print this out with 2 decimal places using this format. One reason I say this is that I've been programming for 30 years and I still never remember, because the problem is I program in like 4 different languages. I never remember in each language how to do the formatting. So even after 30 years, I still almost always Google how to do a format in whatever language I'm currently in. And again, when you get your first job, you might be switching to it might be Java, it might be C#, it might be Python. Each of those has a different format for stuff. So just know there's ways of doing formatting and learn some ways to look that up, or nowadays ask AI to generate that. And you should know enough of it to kind of see what it does. So watch, know that, oh, printf means print with formatting. It has this special thing, and we do a comma and then the variable afterwards, and that puts it into this spot. So if you know a little bit about it, then when you see it again, it'll hopefully make sense for that. All right. So again, Wednesday, we're going to do the quiz